So on this episode, I'm excited to introduce Jacob Strickling, a mechanical engineer who has a passion for science education. So Jacob spent 24 years teaching science in the classroom. That's a lot of years, Jacob. And during that time, he noticed that many students lacked access to hands-on practical experiences. And that has been actually my experience as well as a student back then. Determined to change that, Jacob founded Make Science Fun, a company that provides educational science services. He also created Tiny Science Lab, which reduces the size of traditional science equipment, making it more accessible to students of all ages. I met Jacob a couple of years ago when my children attended one of his online chemistry labs during the pandemic, that was. And I was really impressed. I actually participated in a couple of those online sessions. It definitely made chemistry and science fun and inspirational for the next generation of scientists. And I hope my kids are among those scientists. So Jacob, thank you for joining me in this episode of the Tech Explorations podcast. How are you today?
Very well. Thank you for having me along, Peter, and listeners.
Perfect. So without taking any more time from our discussion, I'd like to invite you to start by telling us a little bit about your story. I call it like the elevator pitch style introduction. So who are you, Jacob?
So born in Sydney, and fond memories from doing science at the kitchen table when I was 5 years old. While my mum cooked dinner, I had a set of candles and matches and cans, and my parents encouraged me to do hands-on science. And I was always that kid who pulled things apart. So I, broken TVs and broken stereos to see how they worked. I could never put them back together, but I was always intrigued. Look, I was naturally good at science as a student. I always went well in the tests and the exams, and I wanted to become an inventor. And so I did mechanical engineering, discovered that I had a knack for teaching and explaining things. So went into teaching, where I was the guy who was always doing the hands-on shows and the practical experiments. Eventually started a YouTube channel where I could do all my fun explosions and projects at home. And then that eventually led to producing Tiny Science Lab, where I am bringing practical experiences to homeschool families, distance ed families, and actually now it's turning out that schools are preferring the small equipment to the regular equipment, which I was a little bit surprised with, but that's just the way it's gone.
Yeah. I liked what you said about, being young. You liked pulling things apart. Screwdriver was working very hard those days. I remember those days. Only I used to do the exact same thing. I left a lot of wreckage in my parents' house. Every time I visit, I still find those old VCRs without the screws.
Yeah.
The only thing I guess that's different is that, I never used to get good marks. My marks were pretty, average. I guess that's then I went into academia. That's a different story, though. So with Tiny Labs, that's how we met. Because we homeschool our kids, so it was a great opportunity to get them introduced into, I guess, science, where we, the parents, are not the teachers or a book. So I found your style really, really good. Like the kids, you're a very excitable person, especially when you're teaching science and chemistry. And that's what struck me. And the kids actually were talking about it. So you definitely had an impact. Maybe could we take a few minutes to focus on Tiny Labs and actually how you started teaching kids? Obviously, you are a teacher, so you spent a lot of time in a classic classroom, but then you took that to the next level with Tiny Labs. So tell us, how did that start? What inspired you? And how did kids and the families accepted you?
Yeah, it's clear as crystal. I remember how it started. I was doing my Make Science Fun videos with normal experiments and normal equipment. And one day I saw an Instagram post of somebody holding up a small little conical flask. And I thought,
Yes.
oh, wow, that's cute. And so I went on eBay and I found out that you could buy little tiny beakers
Well,
as well. And I
yeah.
thought, oh, so what about if I buy a few in? And I started doing some small experiments on the videos, just because I thought it was cute. And I showed some kids at school and they said, oh, you should do ASMR videos with the small equipment. I said, what's ASMR? And it's like that where you whisper, and it's quite creepy. And so I did 5 or 6 of those videos and thought, no, I don't actually like doing those. And then I thought, I really should see if I can find a Bunsen burner. And there was no small Bunsen burner available, but techies will know that you can buy a soldering iron gas burner.
Yeah.
And with a small adaptation, which is just a 3D printed adaptation, and if you put a hole in the table, all of a sudden you can go from a gas torch, and if I show you this, I'll just light it up. It's just butane, which is refillable. And if I light him up, you can actually see the flame there. And if I block off the air holes,
Ooh.
you get the classic flare.
Yeah.
And then I'll just move this back a little bit. If I push that into the table like that, I've got a Bunsen burner in the table. And then, of course, schools need, and everybody needs heat-proof mats. So if I pop a heat-proof mat over there, and then if I get a CNC metal cutter, plasma cutter, and I cut a triangle from a piece of steel, and if I weld some legs on it, I've got the classic tripod, like so. And then from some Termi mesh, stainless steel Termi mesh, if I I pop the Termi mesh there, then I've got the absolute traditional, exactly the same Bunsen burner that I can then get my water, and I can put my water in my beaker and I can boil it up. I can put my chemicals in and that sort of thing. So once I discovered that Bunsen burner, then the whole world opened for tiny science for me, because in my mind, it's the first time we can have a proper burner at home, not just like a methylated spirits burner with large equipment. By shrinking it, it just becomes far more accessible, far safer, far quicker, uses less chemicals, and for homeschool families, absolutely perfect, because they can now do the same experiments as the kids at school.
Yeah.
But because I was a teacher and a YouTuber, I could also then write the worksheets and produce the videos. And so now I'm offering the golden trifecta, I call it, the equipment, the workbooks, and the videos. And so now it's scalable to around the world. Remote schools, remote students, they can have the same, if not better, experience than traditional schools. Because one of the big problems with traditional schools, and I taught for 25 years and I wasn't aware of the problem. But when schools do practicals, they have 4 students around one bench, and only 1 or 2 students did the work. Now, I knew that was a problem, but I didn't think there would be a solution. So I never thought about coming up with the solution. I didn't even think about it. I just went with it. Then when we started homeschooling, I developed this equipment, and for my own children. And then I got children like your kids to come to our place, and we had groups of children. And one day I had a room full of children all using this equipment. And then my eldest son walked in, looked around and went, "This would be good for schools, Dad." And I went, "It would be good for schools." And that's why we actually launched our Tiny Science Lab equipment. Now, because it is so new, something like this, it's very difficult to change the way people do things. So it's a slow burn getting it into schools, but fascinating enough. I won't tell you the name of the school, but I was in a school last week doing an in-service with 6 teachers, and I think it was the most expensive science lab in the Southern Hemisphere. It was the very best that money could buy. And at the end of the day, the teacher said, we're buying 16 sets of these chemistry and we're doing it in this room because this room is not actually practical to doing science the traditional way. And so that just was like, this is just going to be huge.
That's so interesting. I guess, okay, so you gave us a story. I think timeline, we're not talking about decades, right? We're talking about maybe 3 years.
Oh yeah, very fast production.
So it's quick,
very short.
So here's the thing: if you look back, thinking about what you've done, the experiences that you had, the feedback that you had, including last week's at that school that should not be named, what makes your approach to teaching science, including the hardware, I guess, different, and what about it causes the efficacy of learning to go that high? Because this is something I wanted to ask you. Of course, kids are having fun, but I wanted to ask you as a follow-up questions after this.
Yeah.
What is your assessment of how much are kids actually learning? Are they just having fun, or are they actually learning chemistry, its fundamentals, its potential, future careers, perhaps?
Yeah. My philosophy has always been to engage the students first. I actually don't like the name of my company, Make Science Fun. I really don't like that name. I like the name Make Science Practical, Make Science Hands-on. I think the student should first learn through exploring and playing. And I'm talking about the shampoo bottle in the bathtub, squeezing it. I'm talking about an empty bucket in the pool where they're underwater and they pull the bucket over their head and they walk around like a submarine. I'm talking about burning candles and looking at them. I'm talking about a syringe and pushing a syringe. I'm talking about blowing up a balloon, popping a balloon, lighting a balloon. I'm talking about putting some all sorts of any type of play with any type of equipment. And so the same thing with school teaching. I would be very, very short on what the method was. I would say what we're trying to find out, giving them a very brief description of the experiment without going into too much detail, but allowing them, it's a directed learning, but through hands-on practicals. And after that, talk about the concepts. So rather than talking about the concepts, what are you going to see? What are we going to learn? First, and then I can refer to, well, when you heated water, did you notice that first there was little air bubbles forming? Where do those little air bubbles come from?
Yep.
What happened? So that has always, and I think the Montessori approach is through the hands first and into the brain. I'm very big on that. Magnets and coils of wire, blowing on a motor, all these, just exploring these concepts. And so that engages the students. And then I actually then hope that they then go on and study because they want to study. And I've actually had quite a few students doing very, very well. And I can tell you, it's not because I'm such a great teacher, and it's not because I sat with them for a long period of time. It's because I guess I inspired them to want to learn, and then I let them go and learn. I was very happy to have big classes of students who were going to fail because they just weren't able to go well in physics. I was just overjoyed to see that they were in the class and doing their best. That was all that was important to me. Some teachers try and get rid of the lower students so that their marks are, their average marks are higher. No, I was happy. As long as you were willing, I was happy to assist. Yeah. So hands-on. I've always been hands-on.
Yeah, that's I guess the maker philosophy, where you basically want to engage with whatever you're learning. It's not just an academic activity, learning, like it's a whole body activity. Use the brain, hands, eyes. Correct. I always thought of this style of learning as kind of slow food philosophy, where fast food, you just basically want to go through the curriculum as fast as possible in order to mark it off your list of, as a teacher, of list of things that you've got to teach your students. got that
Yep.
milestone, got it, oh, dang, bang, bang, bang. I guess this approach that you are having, where every kid has got his or her own kit and then tries those experiments. I remember the ones that I participated in, they actually take time. Just to do one experiment could take a whole hour of the lesson. So this is something that if you just focus on the book and the whiteboard could take probably 5 minutes, right? So you can't put too many of those experiments together. But the impact to me and with my kids and with my own experiences in this maker education style, the impact is far greater, because then you engage, as we said, everything, and that opens the appetite to actually go out and learn. And what you said earlier is like, after the experiment is completed, however long it takes, you can then start talking about how did that air bubbles formed, where did the air come from? And I guess that's when you can start going into the kind of background of science, the deep end of science, right?
Correct. And then the application as well.
How is this
Fish
useful?
kills in warm lakes, the air bubbles out during on a hot day. And so they will link that heating water in a beaker to that fish kill, and it will bring it alive for them. And there's just so many principles like that, putting carbon dioxide into a bottle, putting it into the sun, and then, measuring the temperature over time. That then introduces them to global warming. And they'll go, plastic and the gas, it increases the temperature. And then, of course, doing it with a control so that you can think scientifically. So I'm very big on scientifically thinking, collecting data, graphing, looking at relationships. So I love.
Can you speak a little bit more about the scientific method now? Because I guess times we live, right? What is reality?
Yeah.
People are saying, and why should I believe that information? Of like, how do we train the next generations, not just of scientists in this case, but of people that will be able to sort out these cows that we call everyday life? What can they learn from your classes, from your method, which I guess that's where the scientific method comes in?
Look, the classic scientific method is to come up with a problem or a question that you want answered, and then developing a fair experiment to test that. So it might be something like, does the temperature change the viscosity of honey? And so straight away you've got temperature and viscosity. And so we talk about an independent variable. That is the thing that you're testing. And so it will be temperature. And so you're going to be changing the temperature, but keeping every other aspect of the experiment the same. And then the dependent variable will be the viscosity. And so if you do that time after time after time, you can test things like, does the tongue have a different framework for testing different flavors? When I was in younger high school, we did an experiment. The teacher told us what to expect. The book told us what to expect, and that we were told that the tongue had 4 zones: sweet, salty, bitter. And because we were ingrained to think that, we did the test and we discovered that the tongue indeed had 4 zones. But in actual fact, that was rubbish. And it's totally disproven. But it was passed from teacher to student to teacher to student because of the ingrainment and not because of an unbiased experiment. So really you have to come to experiments with a bit of an unbiased mind, and to actually approach it fairly. And so fairly, we shouldn't have been told up front what the zones of the tongue were. We should have had a blindfold on and thought about how to control the different variables. And that's exactly what someone did. And after 100 years of scientific rubbish, they actually showed the tongue was like, which is really what you'd expect normally anyway. Like, who would think the tongue would have 4 zones? That's
yes,
right.
Now, of course, it's common sense. But common sense, speaking of that, could you give us some examples in again, drawing from your experience and your experiments that you do with kids, where you ask one of your students, we're going to do this experiment. What do you think is going to happen? And pretty much everyone says, this is going to happen. And then you do the experiment and something totally different happens, which means the results of the experiment don't actually meet our common sense expectations, which I'm asking this because it's very common these days to quickly make up our mind with no sufficient data and no actually need to investigate further. And I'm guessing from your experience, how kids react to that discrepancy between what actually comes out of the experiment and what they expected, and maybe that teaches them something about real life.
Yep. So you've asked a question I wasn't expecting. So while you're asking it, I'm thinking it quite. But thankfully, I've come up with one. Balloons, and if I blow up one, quite big. Now, normally I have the tube, and if I blow up the other one quite small, normally I've got the tube between them with a valve that I can turn on and off. And I will show that to the children, and I say, when I open the valve, what do you expect to happen? What's your prediction? They're joined with a tube so the air can flow between them. I've got a large one which is orange and a small one which is yellow. And so, Peter, I'll ask you, what do you expect to happen? What's your prediction?
My common sense would tell me that the pressure would equalize between the two balloons and that eventually they'd be the same size, right?
Yeah. But then you're also saying he wouldn't be asking a common sense question. That is correct.
Here.
So in actual fact, I can tell the viewers that the small balloon will get smaller and it will blow up the big balloon.
What?
That is a little bit surprising until you think about it a little bit more for a little bit longer. And that is, when you blow up a balloon beforehand, sometimes you stretch it to make it a little bit easier to blow up. And so when you actually blow the balloon up like this, the actual stretchiness of it is less. Whereas when it's only a little bit, there's quite a lot of stretchiness pushing. And so that actually pushes the air into the big one, which is already stretched. And so that then gets kids to think about elasticity, the storage of energy, pressure, particles moving, kinetic particle theory, material science. So the world just opens up with such a simple little experiment. So I'm dreading the day that they ban balloons because, half of the scientific knowledge will disappear from the world. So straws were one matter, but balloons could be another problem.
I guess I answered this way because I was thinking of what happens when you've got water in two different containers that are connected with a small pipe in the bottom, and there's only atmospheric pressure on pressing against the surfaces of both containers of water, and in every case they do equalize. So I thought, I can take that experience and that knowledge and put it here in this situation, and it will work. But no, it doesn't, right?
Not this time.
Different situations. So question twice. Ask multiple questions. Even if something simple, the result may surprise you, which is what I really like about science. Not everything is common sense. Like even at that level, that like the macro level, things can surprise you. That's why I think it's a really good proxy for learning how to think. I don't think you can get so much with mathematics. With physics, definitely. But it's I guess physics, chemistry are those places in science where you can really learn how the world works, and it's not how you think.
Yeah, and look, one thing I had as a teacher, it's not here, but I'd have a bookcase full of equipment, lots of little, so that when you just mentioned the water equalizing, I'd have that piece of equipment, and I could then show the children. I'd often have things on hand, which would then I could use as a student asked the question, like, let's have a look. And that really accelerates your teaching. So sometimes when I did online classes, I'd have trays, there'd be tuning forks and candles and straws and magnets, and a kid would ask a question. I'd say, just a minute. And I'd say, oh, look at this. And then I could burn a piece of
here you
steel
go.
wool or something like this. That's where real teaching comes in. Online makes it very. It's a difficult thing to do online because your mind is just trying to keep track of the children, the experiments. And so online teaching I find very, very tiring. But you can do it well if you've got access to good equipment, that's for sure.
I guess what you just mentioned is a really good example of the value of the teacher, because right now, like I do that myself. I record my lectures and put them online. I don't have live lectures. But what you just said, where a student asks a question, you go to your equipment, you bring out what's necessary to do a experiment, ad hoc experiment, demonstrate to the student the effect of what they just said. I think that's a value where a teacher can make a huge difference compared to what online teaching is about. I guess you do a lot of that, right? Most of your work is online. Most of your work is live.
So not anymore. Me personally, I'm trying to scale, and the only way that I can scale is producing the video on demand. However, there's quite a lot of clients who do want the on live that I've just talked about. And so I'm setting up, I'm finding teachers who are like me, and I'm supporting them with equipment and resources. Right. And so scaling it with other people doing it. I find I don't have the time. The only time I do it now is when I'm developing new equipment and new sets, and then it's spectacular. Because rather than just developing an equipment and taking it to the market, I can test the equipment with 20 homeschool children, and I can watch and you can see a lot. You can actually see, you can oversee those students online far better than a classroom. With a classroom, often the kids, their backs are to you, can't see what they're doing. You have to walk around the room. When it's online, I can say, whoa, stop, Johnny, you're about to do this and that's going to cause an accident. Or, oh, wow, let's all have a look at this experiment, and we can put that on the screen and say, oh, do you notice this? Online has actually, I think it's actually accelerated the visual learning with equipment. And so, and I've had quite a few discoveries online. So for just a small example, I used to fill up my Bunsen burners, holding them with the can here, and the gas would go. And a kid said, "Oh no, Jacob, you put the Bunsen burner upside down in the table." I'm like, "Oh, yes, of course you do." So just little things like that, and even some equipment. A kid goes, "Oh, it broke," and I'm like, "Wow, I have to get that fixed up." And so And the very best thing about it too is that I sell the tickets to online, and so I'm getting paid to develop my own products. So
you get testing in the field.
Correct.
What other tiny labs are there? I know that you were working with some electrical or electronics kids. What's else?
So this is definitely our flagship, which is a chemistry set. I didn't actually bring much today. I've got this wonderful electricity set, which is based on, everybody's probably seen it. It's clip circuit. It's a little clicky things, very simple to set up, but it's made by toy companies. They never actually got a science teacher involved. And so instead of including 3 light globes, they'd only put 1 light globe. And so you couldn't do series and parallel circuits. There was no way to measure the currents and the voltages. So what I've simply done is I have put together a set with 3 light globes, alligator clips on clippies, an ammeter and a voltmeter, and it comes in a case like that. They can even make a variable resistor. And the beauty is, to be honest, most science teachers hate electricity because the wires are everywhere. Sometimes the wires don't work. They can't fix the students' problems. But with the clip circuit, everything's so logical and ordered. They can say, oh, here's the problem. They screw the globe in, it works. And it's just much easier. And you don't need to have a PowerPoint. And in actual fact, it's a lot cheaper. In fact, our whole set is the same price as a normal power pack. And so teachers are really enjoying it. I've done a workbook, I've done the videos. And so I normally say to the teachers, the first time around, if you've got no idea about electricity, let me be the teacher in the classroom with the video. And then the following year, you be the teacher. You won't need me. I'll have trained you via the video. And then you be the teacher, because nothing beats a real teacher. I can tell you that. And a real teacher failing is even better, much better than the most successful YouTube success. Kids don't go home saying, I saw an explosion on YouTube. They go home and say, oh, I saw Mr. Strickling fail again today.
He lost his eyebrows again. It's just,
that's it.
It's happened. So do you tend to record your...
That's the electricity. And then I'm doing like a physics set. And look, this is a maker podcast, and I am not a high-end designer or anything like that. I'm very simple, very quick. The best thing we ever bought, you might think, is a 3D printer, but it's actually a laser cutter. I am a massive advocate of laser cutters. I'll say it. I'll yell it out to the world. Laser cutting is just, you can do so much more and so much quicker. So we make all our foam mats. And we cut lots of cedar. We cut lots of cardboard.
So the table, is it made by your laser cutter?
So this table is, this is one thing that we get made in from overseas. But the cement sheet, we discovered we could actually make with, for a year I was using a circular saw, and then a wet saw, and then one of my workers accidentally dropped one of the and it broke, and we'd been marking them with the laser cutter. We'd just been marking them, scoring them, but then he actually broke it, and it broke.
Oh, there you go.
Like, we could actually score it and snap it. And so these were taking maybe 15 minutes each to make, and it's down to like 1 minute. The laser cutter sped up our process by 15
you don't have to
times.
Be there. So what do you make in that cutter out of all the bits and pieces that are in the kit?
So no, with the cutter we make the these cement sheets, and in this particular set we make the foam. With the electricity set, I make a few little cutouts, but also make a solar-powered car set. And the solar-powered, it makes the chassis, it cuts the wheels out of foam. We also make trays. I do a lot of engraving with it. So we engrave a lot of our products very quickly. So there's a lot of, we use it for a lot of branding.
Multi-tool.
And then we do do a fair bit of 3D printing. But we get that normally done somewhere else. So for example, so the thermometers we use, we just buy these in, but this you can't sell that, right? It's illegal to sell it because the kids have got access to the batteries. But we get these 3D printed, we pop these in there like that, and then all of a sudden you've got a very valuable, marketable product, which is now legal because it's difficult to get to the batteries. And so on, and that fits nicely into our set. So another story is I developed these for our set, discovered that these are fantastic for schools, and so these are now one of our cash cows for schools because they're so much better than a glass thermometer, because you can hold the probe, you can see the temperature live, it's easy to see it, much better than a thermometer. So it's a little bit like the space program. There's been lots of spin-offs that are now good for schools, even like little scales which I use for our set, accurate to 0.01 grams. We now sell them in packs of 8 for the same price as a normal scale. And so I make the tray from recycled cedar wood. We put a foam inlay in, and we sell them for 8. We put the school's name on it. They all love it.
Nice.
And it's all very simple. And it's because I got the biggest laser cutter that we could afford. But we started with a small one. You know, these trays, these foam trays were taking 30 minutes to cut with our first one. And so long time. But then we just bought the biggest, most expensive, the biggest one we could fit. And it's gone from 30 minutes down to 2 minutes. So again, a factor of 15 without math skills.
Yeah,
Yeah.
perfect.
So, and just very simple CAD skills, like the world's simplest CAD skills, because I never go to genius level. I always just go up to
Just
what's
good
good
enough.
enough
Yes.
and then move on to the next project. So don't ask me too many deep questions because I'm just keep moving along.
No, that's impressive, because what I also like is that basically, well, you are a teacher. You wanted to fix a problem in education, but in the course of doing that, you actually built the business as well. And of course, you had to come up and learn everything that's needed to run a business, not just to be a teacher, which is just one level up from what a teacher would normally do, like that works at a school where you can focus on your education.
Yeah.
So congratulations for that as well, Jacob, because I do know that's not easy. that's
No.
just as hard as being a pioneer in education or in any other field. So
you need support.
congratulations.
You need support.
Yeah.
There's no
Yeah.
doubt about it. Don't try and be a self-made businessman. Try and get as much support as you can, which is what I did.
You got some really good solutions, like for example, some of the equipment in the kit, like the little tiny vials, for example. You said, hey, yeah, I can buy that. I don't have to worry about
Correct.
designing it. And you just integrated that into your product, which is really,
Correct.
I guess, out of the box thinking.
The more that you can get that's pre-designed, like for example, if I'll give everyone we paid an industrial designer to design this. Now, this might look very, very simple. And when you see the final product, you say, that's so easy, of course that. But this was about $5,000 in design costs, because what are you going to use to stop it slipping? These are O-rings. But now that you see it, it's obvious. How do you stop that from opening up like that? How many plywood are you going to use? What material are you going to use? How many ply? How strong does it has to be? There's 1,000 questions. And I guess my secret is you just got to make decisions. You just got to go bang, bang, bang. And then I find that I change things later on. That you have to make a decision and you've got to go for it.
Yep.
Otherwise, you just will not come up with anything new if you just can't decide. It's much better to make a mistake or 10 mistakes than not make anything. That's my philosophy.
Yes.
Just do it. As long as it's not going to injure people, I guess that's the most important thing. But if it's not going to cause harm, just do it.
So there's no failed experiment, right? You learn from every single 100%. Experiment. Science. Great. Oh, that's amazing, Jacob. Thank you. So just mindful of time, we just hit the about 40 minutes. So I guess to start concluding at this point, a couple of questions. First, you've had about 3 or 4 years under your belt right now. What's the next 3 or 4 going to look like for you?
Yep. So I've actually just filmed on a fairly major TV show. So we're filming this in June. I can't say what the show is, but I can say it will probably go to air in August. And I think my life is going to change dramatically, because people we're unknown, at the moment. We will become known, and so we are scaling up right now to get ready for when this show goes to air. What that will also do is that will bring the competitors, which in my mind is fantastic, because my equipment, this idea of shrinking, I think it should be a mentality taken on by more. Exactly. And our little old company won't be able to handle this. So competitors will come, and I welcome them. Just like with the electric car, started with Tesla. There's now lots of competitors, and it's good for everybody.
Someone has to start. You're the one.
we made the start, and so I can hand to my heart say that practical science is going to change in schools around the world as people shrink it, and kids will have more engagement themselves. And I'll be a part of that. I'll be a part of that. That's for sure.
That's amazing.
Very
well
excited.
done, Jacob. Yeah. Is it Is it too presumptuous to ask which channels should
I
we
think
be
I'm
looking
allowed
at, or
to
is it a bit
say
early?
it's Channel 10, but
Okay.
but it is a very popular show. Don't you worry about that. I don't, it's,
I'm sure I'll come across it.
everybody knows this show. It's to do with businesses and pitching. But I'm not going to
Oh,
say
okay. I
anymore.
think I know. I think I know what you're talking about. All right. I'll be
Dun
keeping an
dun
eye,
dun dun
and
dun dun.
yeah. I'm sure it's going to go great. There's so many people that actually resonate with what you're doing and what you're saying and your philosophy. And it's not just teachers. So I'm sure
No,
it's going to have an impact. So well done, Jacob.
thank
I
you.
knew it was going to happen because I'm just thinking of my first impression of you 2 years ago. It was during the pandemic as well. And it did make a huge impression, and I thought, well, this is something that I'm very happy to come across, and happy to know it's actually in my neighborhood, pretty much, both
Yep.
of us being in Sydney. So it was striking. So I think it's just a really good evolution and conclusion. Oh, not conclusion, but at this point in time, is how far you've gone. So it's excellent. Well done.
Yeah.
Now,
Thank you.
last question. I'm not sure if you do want people to get in touch with you, but when can people find more information about you, your philosophy of teaching, your products as well? I guess a website, social media, LinkedIn, location where people can find more about you.
Yeah, look, Tiny Science Lab is fairly straightforward.
Type that in Google.
You do a search like that.
Yep.
Just the www.tinysciencelab.com.au. That will see the products. To see my overall philosophy, maybe I've written it down on some channel somewhere, but it's pretty quick to see that I'm just all about hands-on practical engagement without thinking too deep theoretical. I let that come later on for the real teachers, I guess.
Awesome. Well, Jacob, it was a real pleasure talking to you today. Thank you for taking the time to talk to me.
Thank you for listening, everybody.
Bye for now and talk soon.
Okay, bye-bye, everybody.